Hi everyone. So for today we're doing calculating pH. Now syllabus outcome, it's only part of a syllabus outcome. So it's calculate pH, hydrogen ion concentration for a range of solutions. The POH and the hydroxide ion concentration we're going to do in a future lesson, but today we're just going to focus on pH. So revision questions, make sure you've done them. Here are the answers. So Arrhenius acids dissociate to form H+, and bases dissociate to form OH-. Bronsted-Lowry acids donate a proton, and the bases accept a proton. pH 0 is very acidic, pH 7 is neutral, and pH 14 is very basic. Remember, we measure pH on a scale of 0 to 14. Now, pH scale. So we know pH exists on a scale from 0 to 14, but what does it actually represent? Well, pH is a logarithmic scale that's based on the hydrogen ion concentration within a solution. Okay, so it's all the H pluses that are donated or dissociate in solution, from our Arrhenius acids or our Bronsted-Lowry acids. It's a negative logarithmic relationship. Basically, as the hydrogen ion concentration goes up, the pH goes down. And each pH point we go down, the hydrogen ion concentration goes up tenfold. So what is this? How do we calculate it? We use pH equals negative log 10 H plus concentration. Okay. Where pH it's a unitless number because we've gone through that logarithmic operator. H plus is the hydrogen ion concentration of the solution, and log 10 is a button on your calculator that looks like it's just log. Okay. Now our square brackets always indicate a concentration, and that's what your log button should look like. Okay, so remember, it's always going to be concentration. It's always going to be concentration of H plus, not necessarily concentration of your acid, but we'll get to that shortly. Now, this is our pH scale. You can see at the top that we have a pH of 0 is a hydrogen ion concentration of 1. Okay, as we go up pH, we go down a factor of 10 in hydrogen ion concentration. pH of 2, again we go down another factor of 10, so on and so forth, right down to pH 14 where we have a hydrogen ion concentration of 10 to the negative 14. Okay. Solutions in this top area have an increased hydrogen ion concentration due to addition of acids. Neutral solutions have this hydrogen ion concentration due to the self-ionization of water, which we'll get into in a future lesson, but it's based on Kw, so the self-ionization constant of water. So water itself ionizes a little bit. If it's pure, it's 10 to the minus 7 moles per liter of hydrogen and hydroxide. And the solutions in the bottom area, they have a decreased H plus due to the addition of bases. The bases react with the H plus and lower the amount of the hydrogen ion concentration. Now, to calculate hydrogen ion concentration from pH, we use this formula. So hydrogen ion concentration is 10 to the negative pH. Now, this is one that's not actually found on your formula sheet, so you're going to have to remember it. If you've done logarithms in the past, you should have no issue with it, but I know there's some people that haven't touched on them, so you just have to kind of remember that formula. It's 10 to the power of negative pH. Okay. Now, to calculate the pH of a solution, we first have to write a balanced equation for the dissociation of that acid. And it's because hydrogen ion concentration is not always equal to the concentration of the acid. We can then use the concentration of the acid to determine the concentration of the hydrogen ions, which we can then in turn use to calculate pH. And for all of the calculations today, we're going to assume that they completely dissociate. Do all of them completely dissociate? Well, some do and some don't. We'll get to in the future the difference between strong and weak acids. And basically a strong acid ionizes 100%, donates all of its protons. A weak acid doesn't. but they're a bit more complex calculations that involve K. Okay, so we'll do those in a future lesson, but for today we're just going to assume that they completely dissolve, completely dissociate, and always donate their proton. So calculate the pH of a 0.1 moles per liter solution of hydrochloric acid. First things first, we need to write the dissociation equation. Okay, so it's simple. HCl goes to H plus Cl minus. Okay, it's 1-to-1, so it's nice and easy. Molar ratio is 1-to-1. So our hydrogen ion concentration is equal to the concentration of HCl. So therefore our hydrogen ion concentration is 0.1 moles per liter. And then to calculate our pH, it's negative log 10 of our hydrogen ion concentration, which is negative log 10 of 0.1, which is equal to 1. And so that's our pH. So pH of 0.1 molar HCl is 1. Now, calculate the pH of a 0.1 moles per liter solution of sulfuric acid. This is where things get a bit different. So we know sulfuric acid is H2SO4. When it dissociates, it's going to dissociate 2 hydrogens. Oh, and that should obviously be sulfate, not a chloride. So the molar ratio is 1-to-2. Therefore, the hydrogen ion concentration is going to be double the concentration of our H2SO4, which is 2 times 0.1, which is 0.2 moles per liter. Now, this is the number that we can use in our pH calculation. So because we have hydrogen ion concentration now, we can just plug it in. So pH is negative log 10 of H plus, negative log 10 of 0.2, which is 0.699. Now, third example. Calculate the hydrogen ion concentration of a solution with a pH of 2.8. So this is where that formula comes in that I told you is not on your formula sheet, so you're just going to have to remember it. So pH is 2.8, and we want to calculate the hydrogen ion concentration. So H plus is 10 to the negative pH. So we have 10 to the negative 2.8, which gives us 1.58 times 10 to the negative 3 moles per liter. Okay, so that's how we do that, nice and simple. So, summary for today. pH is a logarithmic measure of hydrogen ion concentration. Each tenfold increase in hydrogen ion concentration decreases pH by 1 point. Our pH formula that is on our formula sheet is negative log 10 of hydrogen ion concentration. And hydrogen ion concentration is 10 to the negative pH. So that's all for today. So please go and do those questions in the workbook, and we'll see you next time.